Subject AC machines 2. Topic is single phase commutator motors. Topic is single phase commutator motors. Here the objectives are important observations regarding the principle of operation of variable reluctance stepper motor. Principle of operation of variable reluctance stepper motor and the micro stepping reduction gear stepper motor advantages of variable reluctance stepper motor applications of stepper motor here the introduction. The operation of variable reluctance stepper motor is based on various reluctance positions of rotor with respect to stator. The operation of variable reluctance stepper motor is based on various reluctance position of rotor with respect to stator. So when any one phase of the stator is excited, it produces its magnetic field whose axis lies along the poles, the face around which is excited. Then rotor moves in such a direction so as to achieve minimum reluctance position. The rotor moves in such a direction so as to achieve minimum reluctance position. The minimum reluctance position means a position where axis of magnetic field of stator matches with the axis of passing through any two poles of the rotor. Here the minimum reluctance position means where axis of magnetic field of stator matches with the axis passing through any two poles of the rotor. Here the important observations. The following observations can be made from the principle of operation of stepper motor. The following observations can be made from the principal operation of stepper motor. Here And the phases are excited in the sequence A after B after C then after A. This is the sequence A B C A B C. This is the sequence. When the phases are excited in the sequence A B C A, the rotor moves in the anticlockwise direction. The rotor moves in the anticlockwise direction. So now when the phases are excited in the sequence C B A C, the phases are excited in the sequence C B A C, the rotor moves in the clockwise direction. So here CBAC sequence is nothing but here the rotor moves in the clockwise direction. So here the step angle alpha s is given by alpha s is equal to 360 by np. The step angle alpha s given by alpha s is equal to 360 by np. 360 by np, where n is equal to number of stator poles and p is the number of rotor poles per rotor teeth. So here the step angle alpha is nothing but it is given by alpha s is equal to 360 by n into p. That is n is number of stator poles and p is number of stator number of rotor poles per rotor teeth. So far 3 phases and 4 rotor poles. So for example, if we have 3 phase and 4 poles, see here, so here n is the number of stator poles, p is the number of rotor poles. So for 3 phase and 4 rotor poles, the step angle. In generally here the 3 phase means here they take n is 3 and the rotor poles p is 4. So here the step angle is alpha s is equal to 360 by 3 into 4, that is equal to 30 degrees. 30 degrees. If the number of phases are increased to 4, if the number of phases are increased to 4 and the number of rotor poles to 6, then the step angle is becomes 15 degrees. The number of phases are 4 and the number of poles are p is equal to 6, then step angle alpha s is equal to 360 by 4 into 6, that is 15 degrees. So here micro stepping. If the stator have 3 phase and 4 rotor poles, the step angle is alpha s is equal to 360 by 3 into 4, that is 30 degrees. That is 30 degrees. We have assumed that the winding are excited one at a time. We have assumed that The windings are excited one at a time. If the two phases are excited simultaneously, keeping A dash excited, the B dash is also excited with the switch SW1 and SW2 closed. The two phases are excited simultaneously, keeping A dash excited, the B dash is also excited with switch SW1 and SW2 closed. Then the stator magnetic axis to a mid position rather than along B dash. Rather than along B dash. Here micro stepping, hence the rotor gets aligned. Hence rotor gets aligned along this moves through a half step. Here hence rotor gets aligned along these moves through a half step 15 degrees. So normally the step angle is reduced by factor 1 by 2, 1 by 5, 1 by 10, 1 by 16 or 1 by 32. So this technique is called as micro stepping. This technique is called as micro stepping. A further reduction in step angle can be achieved by increasing the number of poles of the stator and rotor by using reduction gear mechanism. See here the stator and here the rotor given. Stator here this is the rotor. This is stator pole. This is the stator pole. These are the rotor poles. So here reduction gear stepper motor, both stator and rotor have toothed structure. Here see here this is toothed structure. So both stator and rotor have a toothed structure as shown in figure. Each stator may have 2, 3 or 4 teeth. Rotor has more number of teeth, example 10, 12, 18, depending upon the step angle. For example 10, 12, 18. When the stator and rotor teeth are aligned, the reluctance of the magnetic structure is minimum. When the stator and rotor teeth are aligned, the reluctance of the magnetic structure is minimum. If a stator is designed for 4 phases, that means 8 poles and rotor has 18 teeth and 18 slots uniformly distributed around when any one of the 4 phases is energized. Then the electromagnetic torque. Then the electromagnetic torque produced changes rotor position. So now such the rotor teeth under excited phase are aligned to the stator teeth of the same excited phase. Phase are aligned to the stator teeth of the same excited phase. With this arrangement, the step angle reduces to 5 degrees. When the next phase energized and previous one de-energized, the rotor is rotated through a step angle and this sequence is repeated. In the next phase energized and previous one is de-energized, the rotor is rotated through a step angle and this sequence is repeated. By choosing different combinations of number of rotor teeth and stator faces, any desired step angle can be achieved. By choosing different combinations of number of rotor teeth and stator faces, any desired step angle can be achieved. So here the advantages. Here advantages. The variable reluctance stepper motor has following advantages: high torque to inertia ratio, high torque to inertia ratio, high rates of acceleration, high torque to inertia ratio, high rates of acceleration, fast dynamic response, fast dynamic response, simple and low cost machine, simple and low cost machine. Rotor construction is robust. Rotor construction is robust due to absence of brushes. Rotor construction is robust due to absence of brushes. Once again, advantages: high torque to inertia ratio, high rates of acceleration, fast dynamic response, simple and low cost machine. Rotor construction is robust due to absence of brushes. Now applications. Due to its compatibility with digital equipments, its market is greatly increased in recent times. These are widely used in XY plotters and recorders. XY plotters and recorders. Floppy disk drivers. Numerical control of machine tools. Numerical control of machine tools. Process control systems. Robotics. Printers. Tap drivers. Tape drives. XY plotters and recorders floppy disk drives, numerical control of machine tools, process control systems, robotics, printers, tape drives, spacecrafts, and digital watches. Here, the summary is when the state R phases are excited and the sequence ABCA, the rotor moves in the anticlockwise direction. And the state R phases are excited in the sequence of CBAC, the rotor moves in the clockwise direction. The rotor moves in the clockwise direction. The step angle alpha s is equal to 360 by np. N is the number of stator poles and the p is the number of rotor poles. The two stator phases are excited simultaneously. The step angle is reduces. Normally, the step angle is reduced by factor of 1 by 2, 1 by 5, 1 by 10, 1 by 16, 1 by 32. This technique is called as micro stepping. By choosing different combination of number of rotor teeth and stator phases, any desired step angle can be achieved. Stepper motors are used in X-ray plotters, tape drives, printers, floppy disk drives, etc. Thank you.